So welcome to the Node.js Diagnostics Working Group deep dive on CPU profiling. We're going to work through some of the tools and how we get work on the documentation. And Matthias is going to lead the discussion today.
Okay, so I created the doc so we can discuss the CPU use case. I suggest we don't focus only on CPU profiling, but on a more general, my application is running slow. It seems to be a CPU bound related issue and which tools are available. Similar to what we did so far with other tools.
Sounds good.
Let me just share my screen. If I know how to share my screen. Okay, can you see it?
Yeah.
All right. So this is what we had before in the repository. It was not driven by use cases, and I think we should start listing use cases. So, for example, it's just say using a lot of CPU. This is a CPU-bound issue that can be seen in profilers, but also can be seen in other tools. Time spent on event loop, for example, is another common performance issue. Although those are not use cases, those are more like symptoms.
Yeah, or causes, or like, is there more than the general use case of, hey, I notice. I guess you could have a, one where you're using a lot of CPU, but everything is fine. And you just want to reduce your cost. And then you could have another one, I'm not sure how different it is, where you're using, like, your application is running slowly, right? Yeah, those two.
Yeah, the second one makes a lot of sense. It's a very common performance-related issue.
Yeah.
Application is running fine, but I want to reduce cost. Any other use cases folks have in mind?
I guess you could see spikes of CPU usage.
Spikes, that's a good one. Slowness over time.
Yep.
I'm not sure if we should include latency related use cases here, or if that's another discussion.
Yeah, latency, because latency might not have anything to do with CPU, right?
Yes, sometimes it has nothing to do with CPU.
So maybe treating that one separately does make sense. There could be some overlap, but it doesn't seem to fit in a CPU set of use cases.
Yeah, it should probably be a separate document then.
Although even you could say my application is running slower than it should, that could also not be related to the CPU, but.
True.
Isn't it the first use case cover the latency in some sense? Because
yeah, it
eventually,
depends on slow, what that means.
If you're dealing with a web server, slower can mean latency. or just requests per second. Although requests per second usually falls more under cost.
I mean, if we want to change the first one to restrict it to CPU, it could be like, I'm using 100% of the CPU, or, it's like you're using more than you'd expect even, or my application is using more CPU than I expect, or.
Yeah, I'm thinking if it's worth limiting the discussion to CPU or more general performance analysis.
Right. Yeah, maybe it's better to just leave it generic, and because really when you have the problem and you don't know which it is, it's kind of better to be able to start at, okay, how would I even go into the different directions, right?
Mm-hmm. Okay, so
Yep.
let's start with those three, and if we think of any other use cases, we can add later.
Yep.
Slower than it should. Okay, so what are the symptoms for this use case?
We just mentioned longer latency.
Longer latency, web servers.
Lower throughput.
Yeah, this one applies to more than web servers. If you have, for example, a heavy CPU processing tool,
Yeah.
you would experience lower throughput. So that's a good symptom.
Even the latency could be like anytime you make a request. So it could be a web request or some other kind of request. The latency of responses.
I'm gonna, yeah, it's better.
Maybe it's high CPU.
Yeah. High CPU usage.
Although maybe that fits into some of the other ones, the other use cases. Yeah, probably, because that's like the first one is like, I've noticed that my app is running slower than it should for some reason. And then the next one where it's running fine, or I see spikes.
Yeah, I think high CPU usage is a symptom of the first two use cases. So running slower and wanting to reduce costs. And
Yep.
then that's not really a symptom of spikes. A symptom of spikes is spikes. So
It might be like consistent high CPU usage.
yeah, that's better. I think those are the ones that can be observed without any specialized tool. Besides these ones, I think we start going to how to debug the issue. So let's start discussing which tools can be used or which techniques can be used to diagnosing. Anyone wants to share their workflow when analyzing this kind of issues? Otherwise, I
So
can. Yeah, go ahead.
yeah, if you're looking at the profiler, one of the workflow would be apply the profiler for the running application, collect the profile data once after the application has completed running, and then do the process to generate the profiling logs, and then look out for the number of samples against each of the methods, as well as the tree structure of the usage of CPU, which essentially shows the cumulative usage of CPU in one method and the split up of actual CPU samples spent within the span of the method. And the methods could be library methods, C++ methods, or JavaScript methods. One other thing which I don't know whether --prof supports is whether you can collect the samples for a predefined period of time, or should it run for the whole course of the application. Now, if you take the performance analysis, the problem determination comes into two categories in some classification. For example, I want to run the test case or the workload for its whole course of duration, allow it to run and collect the samples or logs, or I want to run for a predefined amount of time, or I want to run the profiler when a method enters up to the point when the method is completely executed. Basically, custom controlling on the trigger of the profiler.
Right, but --prof can only be used for full execution, right?
Yeah, that's what I'm thinking. Yeah.
Okay, did I miss anything on the write-up?
Unfortunately, I can see only part of your screen.
Oh,
Like,
okay. I shared
probably.
the link on the chat if you want to open it.
Okay.
I can see that section, although it could be a bit bigger. One thing I was wondering is, do we need to like step back a little bit? Like this is once you've said, hey, I'm sure I'm using CPU, like I'd probably start out with, okay, things are running slowly. Can I see if I am using a lot of CPU or not? So I'd start by looking at like a top, or on Windows, the process monitor, or maybe something like Diagnostic Report does have a section which gives you the CPU usage. And so it'd be like, my first thing would be to say, okay, do we have evidence that we're using a lot of CPU? Some steps to confirm that.
I thought we are talking about the first scenario, which is longer latency. Is that right?
Yeah.
Go ahead.
Yes, but longer latency doesn't necessarily means CPU bound. It can, for example, a poorly constructed usage of the event loop can lead to longer latency, and it would not show up as a CPU bound issue.
I agree. Yeah.
So that's kind of where I was just coming from, is like, we see longer latency, lower throughput, or, and I guess we even put in consistent high CPU usage. But for the first two, my first question would be, am I using a lot of CPU? Because that could be the cause. You know, and then two common things are like, if you are using a lot of CPU, I've seen like, you know, the GC, if you have a lot of GC, that might be consuming the CPU. If you're swapping, like that can actually result in like, hey, you're using tons of system CPU, even though you're not doing too much. And then, you know, once you're through that, if you say, okay, I'm not swapping, I don't have, I am using a lot of CPU. It's not the GC, it's not the, you know, I'm not swapping. Then diving into something like the process, the dash prof process is the step that you would take. That makes sense?
That makes sense. I agree.
I mean, and I guess even I'm wondering if things like Prometheus metrics give you data as well. So it might be worth mentioning, like, you know, in that first step of, am I using a lot of CPU? Like you could figure that out through things like top or process monitor if you're local. If you've got diagnostic report installed, you could, you know, generate some of those. You could take a look. If you've got Prometheus metrics going to your dashboard, that might be another way you recognize that.
Prometheus is considered an APM, right? APM niche.
I don't know if I don't know technically what would be an APM or not. It's basically provides you, you know, a standard set of metrics or metrics that you add. But the idea is you can, like in Kubernetes, for example, they just, you know, are streamed out for all the containers, and then there's tools to help you see the results across your containers and graph them and all that kind of stuff. So it may, like, I'm not sure it's an APM in that it doesn't instrument things. Like it's not going to instrument. Maybe I shouldn't say that. There is like guidance and so forth for how you get HTTP metrics, which has a bit of instrumentation, but I don't think it would do everything that APMs would do. So guess where I'm going.
Yeah, I agree.
But mentioning APMs is, yeah, that's also a very good point, because that's another thing that may be telling you, wait a sec, we're using a lot of CPU, right?
Yep. Okay, so confirming this, one of the tools that we can use is Prof. It's probably worth mentioning that Prof is only recommended on development environments or
right
environments at best. If the issue only manifests on production, the first two I would recommend JS developers to go to is the V8 CPU profiler, which can be triggered via inspector protocol.
Now, did we ever come to the, like, I know there were discussions about whether turning on the inspector protocol in production was okay or not?
I think that those discussions have stalled. As of right now, if you send a SIG user 1 to the process, the inspector protocol will be enabled either way. So
I guess what's the concern was around, you can do more than you might want people to do, right?
The concerns were around PII,
right,
personal information that can identify users.
right.
So especially with the tip snapshot.
Yep.
Although there has been some arguments that PII can be identified via CPU profile.
Excuse me, Michael. There are 3 folks.
Oh, sorry.
Promoted.
Yep. Sorry. Let me go there. Participants. I guess maybe we should just include something in terms of the cautions that, you know, you can do this, but it should probably be like, you want to make sure the only person who can get to the inspector protocol port is who you expect once you turn it on, right?
Yeah, I think if you use the signal, by default, it will only accept connections from localhost.
Okay.
If that's not the case, I would strongly advocate in favor of changing so that it only accepts from localhost.
Right. Or we have an option to do that at least somehow. Because I'm not.
There's an option. I'm thinking about the default.
Okay. So yeah, I mean, I think we should document how you should turn it on to get the behavior, which is, you know, like if it's only accessible from localhost, well then, you know, anybody who's on localhost can already do some pretty bad things. So that should be fine, right?
Mm-hmm.
And you're right that if that's not the default, it would be good to consider whether it should be too. But just part of what we do, we should make sure we have the instructions for configuring it that way. And does turning on the inspector protocol, what kind of overhead does that have if you don't do anything else?
0, it runs it on a separate thread. It only executes anything if you are sending comment. Otherwise, it's an idle thread.
Okay, so I think we should say that there too. Just, you know, people will look at the guidance and say, oh, what's the impact of turning this on? So if we can say like, hey, turn it on like this so that, you know, only localhost can access. And by the way, you know, until you do anything else, the overhead is expected to be 0. Of course, I think once you turn on profiling, you will have an impact, right?
Yes, and we don't have an answer of how big that impact is today.
Right.
We have some folks that suggested the impact is high. I was not able to reproduce it yet, but that's probably because the workloads are different.
Right.
And considering that this is the tool that the V8 team recommends to use, that's the only profiling tool that V8 team recommends to use, we should probably figure out a way to reduce this overhead if it exists.
Right.
But that's another discussion.
Right. Yeah. Here, if we could just give expect a significant overhead or just something so somebody doesn't go ahead and do it and then like, oh, wait a sec, you didn't tell me it was going to bring my app to a crawl or something, right?
Yes. So for the V8 CPU profiler on node V812 or above, it can be enabled with the CPU prod flag. Which is good for development, similar to prof.
Yeah, maybe just, yeah, good for development, yeah.
Because it will only output the profile when the program finishes.
Okay. And with the inspector, basically you turn it on, you turn it off, and then you get some results, right?
Yes.
Okay.
Another option is to use the C++ API. Which requires installing a native module or writing your own.
Is that a good option? Like, why would you do that versus the inspector profiler?
If you don't want to enable the inspector protocol for security.
Right. Okay.
It's more cumbersome because it requires a native module, and that's not a native module that can be written in an API.
Right. Yep. Would the advice on that one be that, like, if you're going to do quite a bit of CPU profiling throughout the lifespan of your application, to plan for that in advance and write a C++ module?
Can you repeat?
I'm just wondering, like, when would we recommend it? Is it because if, say, you're in production for the first time, you found a potential CPU problem, writing a whole module and turning it on and off through that seems like a lot of work and something you might not do.
That's a
But if you,
plan-ahead situation.
yeah, exactly, that's what I was thinking. So if it, but in a plan ahead where, like, you think you're going to need to do this and it's going to be common, you could write your module that, addresses and improves on what the inspector protocol will let you do in terms of security and workflow kind of thing.
Yes.
Yeah. And are there any good modules already out there?
I think there are. I don't remember any modules right now.
Okay.
But there are some that use the API.
Okay, because, like, if there was one we thought was really good, or several, it might be worth mentioning those as opposed to write your own, right?
Mm-hmm. So call and plan ahead. So the last.
I expect some APMs may also allow you to turn on the CPU profiler.
I'd say yes, but they are going to use one of these three options under the hood.
Yep. Just if you're a user and you already have a CPU like you already have an APM, the recommendation should probably be to check, does it offer the ability to do some CPU profiling for you?
Mm-hmm. And the third way that the CPU profile can be taken is via inspector protocol.
Okay, yeah, you might want to move the first paragraph down underneath that. Like the one right under, like, be cautious when using the inspector protocol.
Oh yes, that makes more sense.
Yeah, just combine those into one, or.
Oops. Either via the specs or node.js module, a third-party module, direct WebSocket communication, DevTools, or other channels.
Right.
So basically anything that can communicate to the inspector protocol can take the CPU profile.
Right. If I'm in production, is there, like, I could see, like, if you have something where you have the browser involved, Chrome installed, you could use the dev tools to turn it on and get a sample, right?
Mm-hmm.
If you don't have that, what would be the first choice in terms of?
Yeah, that depends a little bit on the, for example, on how fast you can deploy a new.
I'd be, like, assuming there's nothing, like, you can't install anything, because that's often,
So
you're stuck.
It's right now it's cumbersome to take it, although you can. you can use node inspect, which comes with node.js,
Okay.
to connect to the running process,
Hmm.
and then you can run the commands and write to a file. But
Okay.
you have to do all of this manually because you can't pass a script. So basically, have to type every command.
Right. I think we should document that anyway, because that's the case people may find themselves in, right?
There are alternatives. You can load a script. You can have a handwritten WebSocket client. I've done that. It's not fun.
Right. I mean, it sounds like with the instructions, it should be relatively straightforward to use the node inspect that comes built in.
Yeah, it's fairly straightforward. It's just it would be better if we could run scripts.
Right. So I think we should document the you're stuck, you got nothing. But then the next one could be, or I don't know the different orders of how to pitch them, but like it might be like if you can install something, here's the thing you should install and use.
Mm-hmm.
But at the end, it would be, oh, okay, you're really stuck. Here's just some instructions you can follow to generate it. Like we almost want to, I think, in my mind at least, it would be good to have a recommendation that says, when you're putting together your production app, you should do this in advance, right?
Mm-hmm.
And that way you're ready to do it in an easiest way as possible. And then you sort of have the, oh, you didn't do that. Here's your next easiest thing. Oh, you can't do this. Oh, here's what you can always do, even though it's very painful.
I agree. Yes. From experience, the first option, which is what should be done, usually not be the option users will go to because either they already have the application running or they were not aware of the documentation before they had a problem.
Right. That's where, like, I was one on recently, and it was even like asking to get heap dumps and so forth. It was because it was a version that didn't have it built in. It was like asking to get anything changed in the production environment if it wasn't thought about beforehand
Mm-hmm.
is not easy. So.
Okay, so if you need a profile from already running process, users can, if a module can be installed, use XYZ, and then we have to find XYZ.
Yep.
If a module cannot be installed, use node inspect kd and run the following commands one by one, because I don't think multi-line works.
Yep. Okay.
And then I can write comments later.
Yep.
The good thing is these steps can be used for other profiling tools that work via inspector protocol.
Yep. That sounds good. I wonder if there's going to be like, if it's a bunch of manual commands, does it make sense to try and add some stuff to node inspect to make that easier?
Yes, I have an information in the diagnostics repo suggesting that. And I started working on a third-party node library, node command line interface
Mm-hmm.
that basically takes these common profiles from a remote process. And my plan is to try to incorporate that on core eventually.
Okay, sounds good.
So if you're writing a new application, do easy to ensure that it's easy to take profiles.
Yep.
So once you have a CPU profiler, users can use Chrome DevTools to look at a timeline view of the execution. Or there are also other tools that can be used to look at a flame graph if you would like to see things aggregated instead of a timeline.
Yep. Yeah, it's probably almost good to explain that, like, you can, what will the timeline view show you and what will the aggregation show you?
Mm-hmm. So the timeline view is good to find patterns of execution. As well as long wait periods on the event loop, I think, although I never done that using the timeline view.
So like if you have spiky behavior, that one might be the one you want to look at, right?
Behavior. Anyone use the timeline view? I really don't use, so I don't know what to recommend about it.
I don't have anything on that.
Okay. So the flame graph aggregated view is useful to identify hot paths.
Yep.
Over a given period of time. Period of sampling.
Yep.
Over the entire profile. Maybe.
Yep.
Regardless of order of execution.
Now for your workflow, I'm wondering, is there a case where you use like more than one profile? You know, kind of like with heap dumps, you could get a couple of heap dumps and then you compare the deltas between them. Is there a similar workflow for CPU profiling where you take a couple and look for differences, or is it really the aggregate that usually helps?
Personally, I go to flame graphs always.
Yeah.
The timeline for Node.js I haven't found to be that useful, but that's probably because I'm used to flame graphs. I do compare sometimes. Netflix published a while back a tool called Flamescope, which has differential flame graphs. Basically, it allows you to load two flame graphs.
Yep.
And it gives a different view that shows the difference. From my experience, that view does not work well for Node.js because of how esoteric is the stack compared to other environments? Maybe with this V8 profile it works better, but usually I'm using Linux profile, so.
Right, that's another question. If should we be mentioning the Linux profiler? If that's what you're always using, well, I guess it's sort of like if we're going to recommend the V8 CPU profiler, why are you always using the Linux one?
First, because that's what we have implemented on Netflix.
Okay.
So we have all the infrastructure to run the V8, the Linux profile.
Yep.
Although we are considering using the V8 as well.
Okay.
Both serve different use cases, in my opinion.
Right, like the V8 one won't give you insight into like native modules, will it?
No, it won't. It also won't give you insights on V8 internals, node.js internals, libuv, etc. Which most users might not want, but sometimes the issue might be there. So
right. So is it like, does it give you any insight into the C level code?
the V8 CPU profile?
Yeah.
No, it doesn't.
No. Okay. So I think that's like, we probably need to cover both then, right? Like the V8 CPU profiler is good if your problem is in JavaScript.
Yeah. Honestly, for my workflow, I'll probably start with V8 CPU profiler once we have it implemented at Netflix.
Yep.
And if I don't see the answer on the V8 CPU profiler, or if I think that it's on the C++ level,
Yep.
I change to Linux.
Yeah, that makes total sense to me. And that sort of starting from the very simplest things of like, top or whatever diagnostic report to say, is CPU even a problem? Then probably the next easiest is to look at the JavaScript side with the V8 CPU profiler. And then, yeah, if that doesn't show anything, it's possibly at the native side, let's turn on the native type tools.
Mm-hmm. Agree.
So yeah, I like that flow.
Should we describe how to analyze these tools? We would probably need some screenshots, etc.
Yeah, I think that would be good.
Mm-hmm. Okay. So the last one I think is the system profilers, Linux profiler.
Mm-hmm.
As we discussed, it's useful, and V8 CPU profiler doesn't give you enough insights on what's happening. Doesn't show any.
I would make it's useful when this, it's the next step when the V8 CPU profiler doesn't show anything at the JavaScript level.
Okay,
Because it's not necessarily going to give us any more insight at the JavaScript level, right? But it will show things that are not at the JavaScript level that weren't there to be seen by the V8 CPU profiler.
Yep, it makes sense. There are a lot of caveats using Linux perf. You need to run with a sudo user. Should we list those?
I know. I think any challenges, like yeah, you're going to need to be able to do this. You need blah, 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 and blah. And you probably, you know, because people will need to get the approval agreement for all that kind of stuff in advance, right?
I don't think perf works if the kernel is locked down. I'm not sure though.
That would be worth checking. And you need it installed too, right? I don't think it's necessarily installed by default.
No, it's not.
So again, that's like if you want to be ready, knowing what you have to install is like, we'll let you do the install if you can, but actually, you know, installing perf on a live production system.
Yeah, and besides installing, you need to start node.js with the appropriate flags.
Right.
You can't. I mean, if you don't care about the JavaScript frames, then it's fine.
Right.
But usually you care, so the flags are important.
Yeah. So documenting those different things, and then it can be for this reason we recommend you do these things in advance. You know, it's kind of interesting. Like, for example, the default community node containers, should we be trying to get them so that they include perf?
No, because
no? I guess that doesn't work anyway because they're in containers.
Yeah, it works on the container if you start the container in privileged mode.
Right.
Which you should not do in
Right.
most cases.
Yep. Yeah, no, I guess the workflow there is different because you're going to have to start perf on your underlying platform, which is not always easy.
Yep.
But yeah, I don't think we should get bogged down. Though figuring those out are one of my goals as well, but I think we should figure out the simple case first. And actually saying at this part up front, though, identifying that, by the way, you're going to have a challenge doing this in containers is probably good so people don't waste their time, right, if they are running in containers.
Mm-hmm. So one of the flags can actually cause more problems, which is why there is a module.
Right.
Let's see, sudo access, install perf by default. If running on container environments, install perf on the host.
You might say install perf on the host. We'll need to investigate from the host too.
Mm-hmm. I think those are the requirements.
Okay.
I
think as an aside, we're at time.
Yep. We can continue in 2 weeks.
Yeah, I think that would be good. I think we've got a good start, but still more.
Okay.
Okay. Thanks.
Thank you all.
Yep. Talk to you later. Bye.
Bye.